Okay, so square roots, or roots in general. We state, I don't know if you can see this clearly. Okay, so x to the nth power is equal to a. So then x is in an nth root, right? We just learned a few chapters ago about powers, right? When you have n as your power, right? We're going to write it in the opposite direction now, right? So x is the nth root of a. So we have this new symbol called a radical symbol right here. Let me use a lighter color. So this radical symbol right here, um, it's spelled radical sign, right? Um, so again, you know how we have 3 squared is equal to 9, right? So that power represents the root of 9. So we have the square root of 9 is equal to 3. So I'm sure you have learned this before, right? This is called the principal root, where we're talking about just the positive square roots. So every positive number has 2 square roots, one positive and one negative, right? Um, so we should realize when we're talking about both roots, we have a 3 squared equals 9, and we have a negative 3 squared is also 9, right? So when we talk about the square root of 9, there are 2 um, roots. So don't forget that. We'll be dealing with that more when we have equations, radical equations. Okay, so in some cases we do a negative square root. Not to say so when the negative's in front, not to confuse it when you have um, oh, oh shoot, sorry, not to confuse this with radical negative 9. Not the same. Okay. This we're going to learn soon is actually undefined. Okay, so when you have a negative square root of 9, that's the same thing as saying minus square root of 9. So this number right here is equal to 3, right? Square root of 9 is 3, so you have negative 3 as your solution. So if you want to write both square roots, right, both signs, we just learned about this plus or minus sign before on Wednesday, right? So when you have plus or minus square root of 9, you can write the solution as plus or minus plus or minus 3. So there are 3 components to a radical, as you can see here. The number inside the radical symbol, under the radical symbol, is called the radicand. This is the radical symbol, and the number that goes into this little area here is called the index, right? That's the root. Okay. So let's evaluate a few radicals. We have the square root of 49. So basically, we have to think about what number to the second power, right? What number squared? So notice there's no index written here. When it's empty, that's by default the square root. So the square root of 49 is equal to 7, right? Negative square root of 49 is equal to negative 7. And then the plus or minus square root of 49 equals plus or minus 7. As I just mentioned before, when you have a negative number under a square root, it's not a real number, right? Not a real number is undefined. We're going to learn this later on. It's called imaginary. So let's examine this a little more carefully. Why is this undefined? So think about this. X equals the square root of negative 49. So by the earlier definition, right, we said, so this is our square root. So that means x squared has to somehow equal negative 49. But if you think about this, is there such a number that you can square and get a negative number? No, there isn't, right? There's no real number that you can do that. Every number that you square, or every real number that you square, is equal to a positive number, right? For example, if I did 1 squared, we get 1. 2 squared is 4, right? Even if I did negative 1 squared, what is that? That's still positive 1, positive 4, right? So that's why these are imaginary numbers, meaning not real numbers. Okay. And by the way, when you're learning this, these radicals, it's a good idea to know these at least up to 12. If you can go higher, that's great. 5 squared, 25. 6 squared, 36. 7 squared, 49. You know how to do these, right? Um, Let me just, I guess, do up to, I'll just write up to here, 64, 9 squared, 81, 10 squared, 100. So everyone should know these, right? Then we have 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196, 15 squared, 225. All right, and then these are optional, but if you do know these, that's really good. 16 squared, 256, and then 17 squared would be 289. 18 squared, oh, forgot the squared here, is equal to 324. Yeah, 324. 19 squared is 361, and 20 squared, 400. So obviously these are more optional, but up to at least 12 squared would be good to know. Actually, even 13 and 14, 15. So if I were you, try to at least get up to these. Right, 13 squared is 169. 14 squared, you just flip the 6 and the 9 to 96. All right, and then 15 squared is 225. All right, so try these on the bottom if possible. Square root of 64. What do we get for that? You could type these answers out in chat. Should be pretty easy. Part A, B, and C. Also D. Okay. What about the rest of these? So we know that root 64, okay, good. Root 64 we know is 8, right? Because 8 squared gives us 64. We know this is negative 8, right? Because root 64 is equal to 8, and this is minus 8, so negative 8. Same reason, this is plus or minus root 60, I'm sorry, root 64 is the, oh no. Let me zoom in again. So this is plus or minus 8. And last but not least, for this one, I would put undefined for now. Later on, we're going to solve the solution as an imaginary number. But for now, since we're just starting, undefined. Very good. Okay. The cube root, so remember earlier we said square roots, right? We can't have a negative number, right? So if I do a square root of a negative 64 is undefined, right? But we'll see soon that cubed roots are a little different. All right, let's start off with this over here. So the one that's missing is part A, is actually the cube root of 64. So we're looking for some number squared, right? Here, I'll put this as equal to a, right? So a to the third power, a cubed, has to somehow equal 64. What number to the third power equals 64? So let's observe here. We have 1 to the third is 1. 2 to the third is 8. Right? 3 to the third is 27. 4 to the third, 64. And 5 to the third, 125. So these are the cubes that you do want to have memorized. So we can see that cube root of 64 is equal to 4. Right? So by the same definition here, when you have a negative in front, that means this is equal to 4, so it's negative 4. Right? Now, let's go into these cube roots of a negative number. So cube root of a negative number is a real number. Now, there's a good reason for that. Look at this. If we did negative 4 to the third power, what does that mean? That means negative 4 times negative 4 times negative 4. And that's equal to negative 64. So there is a number to the third power that is equal to a negative number, right? Negative 4. Okay, so there previously when we were doing the square root of negative 64, there's no number, right? You can't do negative 8 times negative 8. That's not equal to negative 64, right? This is equal to positive 64. So that means for even roots, right, where the root or is a even number here, like the square root, or even in a fourth root here in part E, right? There's no real number that will be squared or to the fourth power that equals a negative number. So that's why part E is not a real number. You can also write undefined. Okay. If the root is odd, then there are real numbers solutions, right? So cube root here, or the fifth root in parts F or G, right? So for the fifth power, when you have a small number, fifth power increases rapidly, right? So you just have to really know 2 to the fifth power, right? Because basically the other ones are a little too high, but let's just do 1 to the fifth is 1, 2 to the fifth is 32, and 3 to the fifth is 243. So you'll see in your homework all the way up to 243. So the fifth root of positive 32 is 2 because 2 to the fifth equals 32. Versus in part G, the fifth root of negative 32, that means it has to be a negative number, right? So if you do negative 2 to the fifth, that's negative 2 times negative 2 times negative 2 times negative 2 times negative 2, right? Five odd, I'm sorry, five negative numbers. Too early right now. Five negative numbers equals negative 32. Okay, so down here and check yourself too. Let's take a look. Try these, and I already mentioned, right, the different cubes over here, and the fifth powers over here. Okay, so that means the cubed root of 125 is equal to, oh, forgot to change the pen. Oh no. Alright, cube root of 125 is equal to 5, right? So in part B, if it says minus cube root of 125, that's equal to minus 5, right? Or negative 5. Cubed root of negative 125. So again, we see that this is an odd root, right? The index is odd, therefore there can be a negative number, right? So this is also negative 5, right? Big difference here. I just wanted to point out on the side, when I do the negative cubed root of 125 versus the cubed root of negative 125, the final answer may be the same, but I do want you to really recognize the big difference here. So over here, this is 5. This is equal to 5. That's why you get minus 5 or negative 5, right? But in this problem here, this entire thing is equal to negative 5. So yeah, the final solution is the same, but the approach is very different. Okay, so later on you're going to see problems like minus cube root of negative 125. So what does that mean? So when I do this problem, I realize, okay, this is equal to negative 5. So in the end, I have minus a negative 5, which is positive 5. So we're going to be seeing stuff like that. Okay. All right. So let's look at the fourth root of 16. So an easy way to do the fourth root, okay, is to do the square root twice. If you think about it, using the power rule of exponents, when you do a number squared and raise it to the second power, you get x to the 2 times 2 is 4. So it's like doing the square root twice. If I did the square root of 16, right? There's a property later we're going to learn that you multiply the roots. So it's like doing the square root of 4, which is 2. Okay? So that's a little shortcut to help you do things in your head. And the fifth root of 243 is 3, right? Because 3 to the fifth power equals 243. Now what about part F? This root, anytime the radicand is negative, I look at the root. If the root is odd, then I'm good to go. But if the root is even, that means this is undefined. So U and D is good for that. And part G, right? This is a negative radicand, but the root is odd. That means I'm good to go, right? So this is equal to -3. Okay? Any questions with these exercises? All right. So when we're dealing with the principal root, we should still be cautious, right? What are we cautious about? So let's look at the square root of x squared, right? So most people are thinking square root of x squared is equal to x. So let's look at a case where x is equal to 2. Now if x equals 2, that means the square root of 2 squared is equal to 4, right? So square root of 4, and we know the square root of 4 is equal to 2. But let's consider when x is equal to a negative number, right? So we just did the first case, now we're going to look at the second case. When x is equal to -2, we have the square root of -2 squared, right? Well, -2 squared is equal to what? +4. Square root of +4 is still equal to 2. So if you look at the statement, the square root of x squared equals x, it's true when x is positive, but when x is negative, it's not true, right? So we have to put together this idea. So the square root of x squared is equal to -x when x is a negative number. So earlier we studied about absolute values, right? So absolute value 2 is 2, and the absolute value of -2 is also 2, because absolute value means the distance to 0, right? So remember, because of this idea here, we're going to be using absolute values for the square roots or any even root. Okay, let's see here. So that means when we have the question square root of x squared, we can't write x anymore. We have to actually write the absolute value of x. Okay, so let's look at these few examples. Square root of 5 squared is equal to 5, but the square root of -4 squared is the absolute value of -4, right? Because earlier we just did this. Square root of, nope, square root of -4 in parentheses squared is the square root of 16, which is equal to 4, right? But if you're taking the square, you can't just, you know how over here we could cancel out the square root and the square and get +5? But here you can't, right? You can't get a negative number. So you should always write the absolute value symbol to ensure that you get a positive number as your solution. Right? Same with part C. The index and the exponent are the same, so this number is the solution 2, right? But in part D, again, we have a negative number for an even root. You can't write -3 as your solution. You have to write the absolute value of -3. So I hope that makes sense. That's why when you do the square root of x squared, right, you're not supposed to just write x. Because x means if x is a negative number, it would be wrong, right? Technically, you're supposed to write the absolute value of x. Now, in many of the problems we do, they're going to say in the question, consider just the principal root, or the x's are positive for those problems. So in that case, we don't have to write the absolute value of x. So that's what we'll be doing most of the time. So if I don't write the absolute value of x, that's the reason why, because x is a positive number for the problems that we're doing. Okay, so now let's look at check yourself 5. If you have the square root of 6 squared, right, that's equal to 6, right? For part B, if you have that the square root of negative 6 squared, right, then the answer has to be the absolute value of negative 6, which is positive 6. Part C is just 3, and part D is the absolute value of negative 3, which is positive 3. Okay, any questions with this page? Okay. So now that we did the square roots, we're going to look at cube roots. When you do the cube root, earlier we did this, right? Square root of, oh, forgot to change the pen. The square root of 16 squared is 16, right? The square root of negative 16 squared is the absolute value of negative 16, which is positive 16. But in the negative case, we do the cubed root of 3 cubed is 3, right? These cube roots can cancel out, or you can look at it as 3 cubed is 27 equals 3. But in the negatives, right, when you have a negative number, it's still a negative 27, right? And this is a real number solution, which is negative 3. So when the root is odd, there's no need to write the absolute value. And in fact, you would actually get it wrong because you're saying that positive 3 cubed is equal to negative 27, which it's not, right? All right, so this is what we have to remember. Square roots, absolute value, right? Let's look at some exercises here and further drive home that point. We have cube roots, right? Cube root of a cubed is just a. But in this problem, we have the square root, right? The square root of 16m squared. So that gives us square root of 16 is 4. Square root of m squared, right? So we can look at these separately. That's why this is 4, but the square root of m squared, we can't write just m. We have to write the absolute value of m, right? Because they didn't tell us m is positive. So we have to consider the negatives too. Part C, it's odd root, 5, right? Fifth root. So fifth root of 32 is just 2, right? Fifth root of 32 equals 2. And the fifth root of x to the fifth is equal to x. So that's why it's just 2x. Now, part D. We have an even root, right? And we have x to the eighth. This is just x squared because of the power rule. X squared to the fourth power is equal to x to the eighth, right? So in a way, you can even do this. You can do x to the power divided by the root. The exponent divided by the root. And that's equal to x squared. Now you're asking, how come there isn't an absolute value symbol here? Because the solution is x squared, right? Absolute value is to ensure that the answer is positive, right? But any number squared is still positive, right? So that eliminates the need for the absolute value symbol. Okay, so we have the cubed root of 27, y to the 6. So cubed root of 27, we learned earlier. 3 cubed is 27, so this is 3. Cubed root of y to the 6 is y to the 6 over 3, right? Y to the 6 over 3 equals y squared. That's why we have 3y squared. So please take a moment to try these next 4 problems. X square, the fourth root of x to the fourth, right? So the solution is that we have to look at it as 4 divided by 4 is to the first power. So since this is not an x squared, we should write our solution as the absolute value of x. Did you remember to write the absolute value for this one? Only when it's x squared it's not necessary, right? Or x to the fourth. And then for part B, we have the square root of 49 is 7, and the square root of w squared is the absolute value of w. Now we have part C, the fifth root of a to the 10th. So remember, you can write this as a to the 10 over 5 is a squared, and the square eliminates the need for the absolute value symbol. Part D is a cubed root, so we don't need an absolute value, right? Oh, actually, it's fifth root too. So we have cube root of 8 is 2, and y to the 9 over 3. So y to the 9 over 3 equals y cubed. So y cubed. Okay? Any questions with these problems? Okay, moving on. Next, we will be talking about something called the Pythagorean theorem. I'm sure you remember this from school, right? From high school or maybe before that. So in any right triangle, we have, here's a diagram of the right triangle. We have these two legs. One of them is called A, the other is called B, and they are joining at this vertex here by a right angle. And then on the other side of that right angle, there is the longest side of the right triangle, which is called the hypotenuse. Okay, so we call that variable letter C. So the Pythagorean theorem says the leg squared plus the other leg squared is equal to the hypotenuse squared. So a squared plus b squared equals c squared. To find c, you would have to square root both sides, right? So, oh gosh, why do I keep doing that? So we have a squared plus b squared is equal to c squared, and to find c, we square root both sides, right? And because we're square rooting both sides, it's an even root. We have to consider it to be positive only, right? So c is a length, and lengths cannot be negative, right? So this is equal to c. So suppose we have two legs of a right triangle, 7 and 12. How long is the hypotenuse? 7 and 12 represent the legs, right? Because they are right next to the right angle. So we would have to do the Pythagorean theorem. So that means 7 squared plus 12 squared is equal to c squared. And then we square root both sides. So 7 squared is 49 plus 12 squared is 144. And remember, a radical symbol is a grouping symbol. So everything under the radical, we would have to do first in the order of operations. So 144 plus 49 is equal to C, and that's 193. Radical 193 is equal to C. So we have a problem here. Two legs of a triangle are 11 and 14. Please find the hypotenuse. So I will give you a minute to try that. Okay, so we have two legs of a triangle. And if you did want to draw it, whoopsie, what is that? You can draw the triangle like this, or even facing the other direction. Sorry, that's a poor triangle. The legs are always next to the right angle, 11 and 14, right? So we need to find the hypotenuse C. So we have 11 squared plus 14 squared is equal to C squared, and we square root both sides to find C, right? So 11 squared is 121 plus 196, square root of that, and we get, what is that? That's 2, 3, what is that? 3, 1, 7. So square root of 317 is equal to c. Now 317 is not a perfect square, right? So if you throw that into the calculator, you're going to get a decimal approximation. So I would prefer you leave it in radical form. Okay, don't change it to a decimal unless the directions tell you to do that. Okay, now we're looking at a problem where we're asked to solve for one of the legs. So in this right triangle, the hypotenuse is 23 and the leg is 16. So we need to find the other leg. So earlier we said the Pythagorean theorem is leg squared plus the other leg squared equals the hypotenuse squared, right? And if you think about it, that means we have to kind of manipulate this Pythagorean theorem. So we have 16 squared right now. Sorry, let me change this to, okay, so right now we have 16 squared plus the other leg squared is equal to the hypotenuse squared, right? But we want to solve for the leg b squared. So what I'm going to do is subtract this 16 squared. So b squared is equal to 23 squared minus 16 squared. So now b is by itself, I can square root both sides. So what does that really mean? It means when I had a squared plus b squared equals c squared, and I want to solve for b, I had to subtract, right? So b squared is equal to c squared minus a squared. And then you can square root, so b is equal to the square root of c squared minus a squared. So that's what we did right here. So 23 squared, right, minus 16 squared. So that comes out to 273. B is equal to 273. Okay, so just make sure when you read the problem, read carefully. Make sure you know whether the number given to you is either a hypotenuse or a leg, because that would significantly change your outcome. Okay, so please check yourself 8. So I forgot to record that section right there. So we have the hypotenuse is 19, the leg is 12. So hypotenuse squared minus leg squared is 19 squared minus 12 squared, and we square root that. So that's square root of 361 minus 144 is 217. And we want to leave it in the radical form because it's not a perfect square. We don't want to approximate like a decimal number there. So please just keep it in that radical form. Okay, this here is the distance formula. We're going to skip this for now. So let's look at some quick questions and we'll be able to move on. Let's do a few exercises. The ones I want to talk about are down here. Okay, so we didn't talk about these specifically. However, these are very important. These are properties of square root or radicals that we will be covering more of. So I want you to get familiar with them now. So when you have a square root of a fraction, right? This is our property tells us that we can actually split these up. We could split it up like this: the square root of 4 over the square root of 9, right? This is a square root of 4 over 9, so square root of 4 over the square root of 9, and we can do these individually. So that's what, 2 over 3, right? So if we look at this next one here, we'll just do the odd ones, and then I want you to try the evens. What is the cube root of 8 over 27? So you take the cube root of 8 over the cube root of 27. So cube root of 8 is 2, cube root of 27 is 3, right? Square root of 6 squared is just 6, right? However, the square root of negative 3 squared is the absolute value of 3, which is equal to positive 3. Cube root of 4 cubed is just 4, right? And the fourth root of 3 to the fourth is just 3. So I'll give you a few minutes. I want you to try these even numbers. Alright, so we have the 26 is the square root of 9 over 25. So we can write this as the square root of 9 over the square root of 25 is equal to 3 over 5. Right, hope you got that. Now this is a cube root of a negative number, right? So that means this final answer has to be a negative, right? So what I'll do is I'm going to take out the negative first because I know that the answer is negative. Um, or you can actually apply the negative just to one of these numbers. That's entirely up to you. So let's just do it to one of these numbers. So I have the cube root of, let's say, negative 27, right, over the cube root of 64. So that means this is negative 3 over 4. All right, so your final answer has to have that one negative sign somewhere. Number 30 is the square root of 9 squared is just 9. But for 32, right, it should be absolute value of negative 5, which is positive 5, right? Do we need an absolute value sign for 34? It's a cubed root, so we don't, right? We can just write this as negative 5. If you're not sure, if you forget the rule, right, you can just do negative 5 to the third power, right, and still get the correct answer. But number 36 is an even root, right? And your final answer is the 4's cancel out, right? The fourth root and the fourth power. So it's the absolute value of negative 2 equals positive 2. So just before I continue on, does everyone remember when it's an absolute value symbol, when it's not? Just want to make sure.